In this question, we're asked to calculate the power absorbed by each of the resistors in the diagram above. So we have resistor R1 with a given value of 4 ohm, we have resistor R2 with a given value of 6 ohm, and resistor R3 with a given value of 8 ounce. What we have to calculate is the power which is absorbed by resistor R1. We need to calculate the power absorbed by resistor R2, and we need to calculate the power which is absorbed by resistor R3. We know that for calculating the power, we are having a main formula, which is a voltage multiplied by current, which we could use in two other variations. We could either go for power being current square multiplied by the resistor if we don't want to calculate the voltage, or we could go as power calculated as voltage square over the resistance if we want to avoid calculation of the current. So first, let's concentrate on the values which are given. Because we have too many voltages, it seems like it will be much smarter and advisable to try to pick up the given values and, based on the nodal analysis, to pull an expression for the voltage across each resistor, which could eventually lead to using the formula of RH squared over resistance. So step by step, let's see what we know about the voltages at each node. Because we're going ahead with nodal analysis, what I'm going to do first is organize a couple of nodes, and I already have them. I located the reference node, the ground, which is V node, coming with 0 volts. So immediately I could write in here that V naught is going to be 0 volts. That's clear. Now, if I look at the way the voltages and the polarities organized on the diagram, I can see that in that branch here, if I go positive node minus negative, I will have a difference which could be written as V3 minus V naught equals 12. So positive terminal minus the negative terminal, which gives me V3 minus V naught, given as a source of 12 volts. Now from here, I could say immediately that V3 is going to have the value of 12 volts. Now the next relation I can do is related with the 8 volts. Now let's be very careful in here. The 8 volts on that branch, right here, is between V2 and V3, so I could say that positive terminal minus the negative, so it's going to be voltage drop V2 minus V3, coming at 8 volt according to the given value, which immediately pulls out a value at the node V2 of 20 volts. Okay, I could pull a little bit more, moving to the next 8 voltage source, which is the one right here, and I will do the same node analysis. I'm going to go positive minus negative, so follow the voltage drop rules. Voltage drop in here means that V2 minus V1 is going to give me 8 volts again, and V1 respectively should be 12 volts. Okay, so far so good. From here, what I have to do, next step, is organize all the values I got and try to see how can I calculate from here ahead if I'm missing something. So I'm back to my diagram, but this time I'm going to include the values, so it will be so much easier to calculate what is happening after. So let's be very careful. V1, I already calculated as 12 volts, so I'm just going to put in here 12 volts, V2 I calculated as 20, so here is the 20 volts. V3 was 12, so there is the 12 volts, and V0 I know was a 0. Now, at the moment, I could run the nodal analysis and I could calculate the voltage across resistor R2 and R3, but I'm not able to calculate the voltage across resistor R1. What I'm missing in here is the left node. So I need to get that node. I need the voltage in here. Because I used V0, V1, V2, V3, I'm just going to call that node V4. And because I have 6 volts already given as a DC source, I could notate here V5. And now I know that the positive minus negative is going to give me V4 minus V5, 6 volts. Now from here, let us try very gently to work what we have. So first, V4 minus 12. Don't forget, we have a positive minus the negative. So the calculation in here is going to be 4V4 V4 minus 12 equals to 8. Now, from here I could say immediately that V4 value, the voltage potential at not V4 is going to be 20 volts. Okay, then if I go across the battery 6 volts, I will have V4 minus V5 given as 6 volt, which immediately tells me that V5 is 14 volts. Okay, I did not have to actually go for V5 because from here I could do all of my calculations. So let's organize everything we know at the moment about the voltages. So voltage across a resistor R1. And across resistor R1, I'm having V4 minus V1, which gives me 20 minus 12. And that's a value of 8 volts. Now, I could do the voltage across resistor R2 the same way. Across resistor R2, I'm having V1 minus V0, which is giving me 12 minus 0. Now that's 12 volts. And I could do the voltage across resistance R3. Resistor R3 is surrounded by the two nodes V2 and V3, so V2 being positive minus V3 is 20 minus 12, which gives me again 8 volts. Okay, now from here the calculation becomes very easy because I do know the voltages and I do know the values of the actual resistance. So R1 was given as ohms, R2 was given as 6 ohms, and R3 was given as 8 ohms. Now from here, my calculation becomes extremely easy. All I have to do is organize the powers. So the power across the resistance, the power related to the resistor R1 is going to be the voltage square voltage across resistor R1 divided by the resistance of R1, which is 8 squared divided by 4. That gives me 16 watts. Then the power related with the resistor R2 is going to be respectively voltage square measured across resistor R2 divided by the resistance of R2, which I know was 12 squared divided by R2 being 6, which gave me 24 watts. And the last calculation power related to resistor R3 is the voltage square across resistor R3 divided by the resistance of R3, which is again 8 square divided by 8. So this value is going to be 8 watt. So my question is solved. I have the power which is being absorbed by resistor R1 being 16 watt, the power being absorbed by resistor R2 being 24 watt, and the power being absorbed by resistor R3 being 8 watt.